Hello students, it's Professor Howard here, and we just have a lecture here on some different concepts going on with how to reproject something or how to change the projection of a data set. And so there's some really important concepts to understand here. And so the first idea we're going to look at is what's called, well, first we have to understand why we would need to do this. So if you have data sets that are in different spatial references or using different projections, it's very possible that your data will not actually line up correctly because they've been projected to the two-dimensional surface differently. And so when that happens, we have to do what's called a reprojection, where we have to change the projection of a data set. So the first concept I want you to understand here is what's called the native spatial reference. And so the native spatial reference would be the spatial reference a data set has when it's residing in its file structure or its folder. So here we have our ownership here. If I double click on this, and it'll show me where these data are sitting. They're on my C drive, and right here, this GCS North America in 1983. This is the native spatial reference of those data right there, okay? So if you were to look at them in our catalog and right click on it and check its spatial reference, you would then see that it was the same as this right here. And so that's what's known as the native spatial reference. So the first concept we have to understand here is what's called on-the-fly projection, okay, or on-the-fly reprojection. Sometimes you'll hear it said that way. And what that means is that when the software has, you'll see here that my data frame, it has a spatial reference as well, and it usually takes on the spatial reference of whatever's added to the map first. I mean, it almost always does that. And so you'll see it has the same spatial reference right now. It's GCS North American 1983 as well. But if that were to be different, so say that now I added a data set that had a different spatial reference, what the software would do is it would reproject it on the fly, which simply means that for display purposes only, okay, only display purposes, it would show the new data set as if it were in GCS North America 1983. So it would line up correctly with this, but only for display purposes. It did not actually change the native spatial reference of the data that was added. It simply displayed it that way. And I'll show you this here. So if I change the spatial reference of the data frame, the software will automatically reproject the data on the fly and show it as if it's in that new spatial reference. So right now it's being shown as GCS North American 1983. But if I change it up here to North American Datum 1983 Albers, so I click here, and then I click apply, you'll watch it'll actually move. The data will change how it's oriented. And you'll actually see the distortion will change too. It'll look very different here. So here we go. Did you see it? We'll do it one more time. Now it's oriented more north and south now. It almost got like a little bit more squished on the sides. We'll do it one more time. We'll switch it back to GCS North American 1983. 3, 2, 1. Look at that. So you can see that if you had two data sets that were not being reprojected on the fly, they would not match up correctly at all. This would be a significant difference between the two. Is one right and one wrong? No, they just serve different purposes. Remember, when we go from 3 dimensions to 2 dimensions, we're going to introduce distortion. That's just going to happen. And so you can't say that one's better than the other necessarily. So the other way to project the data would be, well, let me first here, let me switch this back to Albers just as an example. Okay, so my data frame is in Albers, but my ownership layer is in GCS. And say that I wanted to get the ownership layer into Albers. There's two ways I can do that. I can search for the project tool, not the project tool, the project tool. So I search for Reproject. And I'm looking for the one that's in data management. Projections and transformations. Project. There it is. So here you'll see that I can input a data set or feature class. I can choose, it'll give me the input coordinate system there. I can then choose the output data set or feature class and then the output coordinate system. So then I could choose Albers there, and it would reproject it and would actually change its native spatial reference for the new data set, and it would be in Albers. This here is important to understand too, where it says geographic transformation. If you're switching, if you're having a significant switch between data sets, so for example, there's one NAD 1983 to NAD 1927, that's such a significant switch between the spatial references that it requires what's called a transformation. And so the software will usually tell you if it needs that, but that's something just to keep in mind, and kind of something you should know, especially for next term, is that in order to go from NAD 1983 to NAD 1927, that requires what's called the NADCON transformation, which just simply means North American Datum Conversion, NADCON transformation. You'll see that emphasized quite a bit next term. But just remember, so this is one way to switch the to reproject a data set. It creates a new feature class in the new coordinate system. Another way you can do it is I can always just do this. This is a pretty slick way of doing it. Is I can right click on the ownership layer and I can go down to data, export data, and then I choose where it's going. But then here it asks use the same coordinate system as, and we always have had that just checked for the layer's source data, but we could do it as the data frame. And so now when I save this out as a new feature class, it's going to give the new feature class the coordinate system that the data frame set to, which is Albers. So that's pretty awesome. That's actually a really slick way of doing it. What I'll do for projects is I'll set the data frame to the desired coordinate system. I'll add all my data for the project, which could be in several different coordinate systems, and then I'll do this. I'll export them all out into their own geodatabase, project geodatabase, and then I know they're all in the same coordinate system. It's really a pretty slick way of doing it. It'll figure out all the transformation needs that you need. In my opinion, this is actually the smoothest way of doing it, but a lot of people don't even know you can do it this way. Now we have to talk about what you should not do. If we search here, we'll see that there's a tool called Define Projection. So this tool is often mistaken as being the project tool, and it's not. Okay? So you'll see here, all this does is you give it an input and you give it a coordinate system, and that's all it does. But the problem with this is it's not reprojecting the data, it's defining the projection. And so just as an analogy, if say that we have somebody named Michael and he has a driver's license, that driver's license doesn't make him Michael. He already is Michael. The driver's license simply defines his identity or tells us what his identity is. And so if we were to take his driver's license and give it to somebody else, it doesn't make the new person Michael. They're still who they were. It's just going to cause a lot of confusion. And so what's happening here is you're telling the software that this data set is in this coordinate system. You're not changing it. You're telling it that's what it is. The problem is if it has numbers that were generated when it was created in a different coordinate system, the new algorithm is going to be applied to those numbers, and it's going to mess it up completely. Okay, because you're not changing the coordinate system, you're telling it what it is. And so what this tool is actually for is, like with a shapefile, one of those files in a shapefile is a projection file. Sometimes those will get corrupted or they'll get lost. Somebody will forget to email them when they send them. And so then the data has numbers, but it doesn't know how to apply them because it doesn't know which coordinate system it should use. And so what you do here is you then, looking at the numbers, you can kind of figure out which coordinate system it was probably collected in, and then you can tell it, hey, you are Albers. And then once it applies the math to the numbers, it'll show up in the right place. And so it's a way of fixing problems. It does not change the actual projection. The same thing with Arc Catalog. In Arc Catalog, you can open up a data set and you can change the projection there, but that is not actually changing it. That's doing the same thing as this. It's defining the projection, and you'll mess your data up. And so it's probably best, until you really understand how this works, to just avoid this tool altogether. You can really mess things up. I had a coworker recently that was just getting into GIS, and she had done this for all of her data, and it was all totally messed up, but showing up in the Pacific Ocean. So it's very possible to really mess your data up using this tool. So remember that reprojecting is different than defining a projection. Defining a projection is simply telling the data what it was collected in, where reprojecting changes the underlying numbers into a totally new projection. And so when you're wanting to fix spatial reference differences in your data sets, you want to use reprojecting, because that'll actually fix it. And it creates a new feature class, so if you do mess it up, it doesn't ruin the original, like this would actually really mess up the original. So I hope that helps you guys. It's not an easy topic, but it is something you really do need to be aware of. And because you'll see that there's lots of errors that you'll see on maps where things don't quite line up the way they should. And that's usually because two of the data sets were in different spatial references and they just weren't paying attention when they made the map. So I do not want that to happen to you guys. I want you to pay attention and to correct those errors. So kind of a shorter little lecture, but some really important stuff. So I hope that helps you guys out, and have a great rest of your week, and I will see you guys next time.
Yes, a wall of haze. Yeah, lies of legends.